All right, welcome back. Let's take a look at page 2. I'm hoping that this isn't going to be too long a one, so let's see how we do. Okay, so this mentions a kite, and sometimes kites are a little harder for people. So let's just see what we got. I'm going to make myself a nice, pretty little kite. I'm just going to make these maybe a unit and a half long, and there we go. And then I'm just going to split this down the middle. So again, I'm not trying to be perfect with this. I'm just trying to make it look vaguely pretty good. And it says in this thing that somehow CD and AD are the ones that are the same. But you notice CD and AD both have the value D. So I could do CD and AD. So it would be A, B, C, D. And now these two are exactly the same length. But that also tells you that part of the definition of a kite would be that AB would be the same as CB. And what do you know? They're telling me what AB is, and they're telling me what CB is. So if AB is this one and CB is that one, then I'm just going to go ahead and set those two things equal. And this time around, just like the previous question, they just wanted me to set them equal and find x. So that's going to be nice and easy. 2x minus 4 is 12. We're going to add 4 to both sides. And then if we just do a quick division by 2, we found out that x is 8. Good to go. That one's done. Now, they're mentioning a new one where we've got a parallelogram and it has a diagonal AC. So let's see. So I want to do a nice job because if I do a good job on all of my diagrams, um, it just makes the math easier to follow. So I'm trying to make these segments look basically the same length, okay? And it doesn't have to be perfect. I just find that that's sort of helpful. And so what I've got in here is A, B, C, D, and it says AC and BD intersect at F. So here's AC and here is BD. And it said it intersects at point F. So they're telling me this value right here, smack dab in the middle, must be point F. That's the intersection of those two diagonals. So going a little bit further, they're telling me that AF is, this guy right here is 18.2. And they're also telling me that FC, this guy right here, is 8x plus 11.2. Well, a nice little feature that we know that is true of all parallelograms is that the diagonals bisect each other. So I know that AF and FC are equal to each other. So let's see, that's 12x minus 18.2, 8x plus 11.2. And again, nothing particularly bad. We just wanted you to find the value of x. So we'll do the just simple thing that we've been doing. Subtract 8x from both sides. I'm going to add 18.2 to both sides. And I guess we don't probably need a calculator because this is 29.4, but I'm going to be a little bit careful because I don't want to make a mistake and put that on video so people can make fun of me, right? So 29.4 divided by 4, if I divided both sides by 4, I got x is 7.35. Now, again, everybody has their own style, but my style is I don't ever trust myself. So if x is 7.35, I'm going to take 12 times 7.35 plus minus 18.2. So I put that in and I got 70 when I put that all in. That was a little surprising. I thought I'd get an ugly number. Now I'm going to try 8 times 7.35 and I'm going to add 11.2 and hopefully I also get 70. So that tells me that what I did with my algebra is consistent. Now, number 7, I'm going to be consistent with myself and draw myself a nice simple rectangle here. And again, it doesn't have to be absolutely spot on perfect, but I'm trying to be consistent with my logic here. And it says it's D, E, F, G. And it says this angle right here is x plus 14 degrees. But the nice thing that I know is that in any rectangle, no matter what, the angles all have to be 90 degrees So I know that x plus 14 has to be 90, and so all I really have to do is subtract 14 from both sides, and I got 76. Done. I guess I didn't even need this if I had read the question and realized that a rectangle only has 90 degrees in it. And then my last one is I've got this parallelogram, A, B, C, D. So we're going to do one more. I'm going to go 0 to 6 maybe here and maybe 0 to 6 here. Again, if you keep them the same length and parallel, it makes it pretty easy to make a pretty nice looking one. Now, this is a case where I kind of know a little bit about this question, and I'm probably not going to make it perfect, but we'll see what we can do. I just made A, B, C, D, okay? And it says C is x minus 1. That's this angle right here. And B is 5x plus 1. Now, this is an unfortunate thing because they're not equal to each other. They can't be. There's something else. If these two sides are in fact parallel, then these two angles, this is a big angle above 90, this is below 90, those need to add up to 180. So we're going to take 5x plus 1, add it to x minus 1, and somehow that sum has to be 180. Now, our author does this a lot. We took this test question from the book, or this practice test question from the book. They do this a lot. A 1 and a negative 1 cancel out, and we just get 5x plus 1 is 6. Divide both sides by 6, and we got x is 30 degrees. And so if I were to plug that back in, this angle right here would be 30 take away 1, which is 29. This one is 5 times 30, which is 150, plus 1 is 151. Now, I think you could probably see it, but let's just double check. 151 plus 29 is identically 180. So it looks like I did okay. So B is 151. C is 29. And we didn't ask you that this time, but we might on the test. Remember, that also makes A 29, and it makes D down here 151 because opposite angles are congruent. So again, be aware that we could switch it up and ask it in a slightly different way. Okay, I'll see you back in class later. Bye-bye.